Hello, this is the video solution for problem 3 from quiz 2. So here we're asked to compute a couple of limits, and we are very helpfully told that exactly one of these limits will exist. We just have to determine which one. And then the one that does exist, we'll have to prove it. The one that doesn't exist, we'll have to show why. So this first one, where we have x over y to the fifth, why don't we try looking at what happens, say, as if we let x, say, be 0, right? So if x is 0 and y is not 0, okay, because again, remember, when we take such a limit, we're never ever going to let xy equal 0, 0. So if x is always 0, then we can assume that the y is not 0. So along this line, then what happens? Well, the x is 0, so I get 0 over y to the fifth. And no matter what y is, as long as it's not 0, this is going to equal 0. And so along this line, where x is equal to 0, the limit would be 0. Okay. But what if we try a different line? Like, for example, in fact, this won't even be a line, but actually a curve. What if we try along the curve x equals y to the fifth? So again, here we're going to assume that our x is not 0, all right, so that the y won't be 0. If that happens, then along that curve, x becomes y to the fifth. The bottom is still y to the fifth, and this, all right, because x is not 0, of course we also know y is not 0, so I can cancel. This is always equal to 1. So along this curve, the value of the function is always 1 as you approach 0, 0. All right, well, this tells you that along different curves going towards 0, you get different limits, which means that the overall limit does not exist. All right, well, the hint told us exactly one of them does exist, so that means it must be B. So let's see how we can show that it does exist. Well, first, I mean, again, maybe we didn't know that. Let's check it along x equals 0, right, where y does not equal 0. Well, in this case, we're going to get 0 squared times y, which is 0, over y squared. And this is always equal to 0. So if this limit does exist, it's going to have to equal 0. All right, a really good way to approach such a problem then is doing a switch into polar coordinates. So you should see the video I made for that. I'll put a link in the description. So switch to polar. So remember, when we switch to polar, we let x be r cosine of theta, y will be r sine of theta, and x squared plus y squared is equal to r squared. And you remember I have my little secret convention where I just write this as RC and this is RS to make my life feel a little bit better. So when I switch to polar, x squared y over x squared plus y squared turns into, well, let's see, x becomes RC, so x squared would be r squared, c squared, and y would be RS. So I get r cubed and then a c squared and an s over, ooh, hey, x squared plus y squared, that's just r squared. All right, well, as I'm heading towards 0, this r, right, which tells you the distance from 0, that's never allowed to be 0, right? So this, because r is not equal to 0, I can cancel, and I just get r times c squared s. Okay, now, as theta moves around this c squared s, you're just going to be multiplying numbers between -1 and 1 together. But then you're hitting it with something which, as r goes to 0, is going to be going to 0, right? We could use the Squeeze Theorem, for example, right? We could say, well, we know that c squared s is always between -1 and 1. And so if you multiply by r, you'd have negative r is less than or equal to r c squared s is less than or equal to r. But we know that these two outer pieces go to 0 as r goes to 0. And so by the Squeeze Theorem, squeeze in the middle, we know that this r c squared s goes to 0. Okay, so we conclude that as you get closer to the origin, right, that's what r going to 0 means, it doesn't matter which direction you go, that this limit is going to equal 0. Now, alternatively, if you don't want to switch to polar coordinates, we can prove this just directly using the definition of the limit. So there's many ways we could do this. Let's copy our problem down here. So we have limit as xy goes to 0, 0, x squared y over x squared plus y squared. And the claim, right, is that this is equal to 0. So what we can do is we let epsilon be greater than 0. And so what we're trying to do is to find some open set around 0, 0, call it u epsilon, which, if you take anything in there, is going to map into the band of radius epsilon around 0. So we would need that every single point inside this u epsilon would get mapped into that band. So that's the goal, is to find this open set u epsilon. Okay, so how do we do that? Well, in order for everything to map in here, that means the distance between the values of this function and 0 have to be less than epsilon. So let's compute that distance. So x squared y over x squared plus y squared. How far away is that? Remember, when you do the absolute value of a difference, it tells you the distance between those, has to be less than epsilon. Right? That's what we want. Well, what does this actually equal? Well, first, you can get rid of the minus 0. Second, we can use that the absolute value of a quotient is the quotient of the absolute values. So this is equal to the absolute value of x squared y over x squared plus y squared, where I don't put the absolute values on the bottom because, well, it's already non-negative. Of course, I now have a product in the numerator, and I know the absolute value of a product is the product of the absolute values. And so I can rewrite this as x squared times the absolute value of y over x squared plus y squared. Again, I don't put absolute values around x squared because it's already non-negative. Okay, but notice here that x squared over x squared plus y squared is less than 1. Right? So x squared over x squared plus y squared is less than 1, right? Because the x squared plus y squared is strictly greater than the x squared, right? Or at least less than or equal to, right? Okay, fine. So that means that this is less than or equal to the absolute value of y, right? This is just 1 times the absolute value of y. And so if I want this whole thing to be less than epsilon, I can just choose my y values, right? So this is what I do, choose my y values to be less than epsilon. So what that means is that I should set my u epsilon equal to the set of all points such that the absolute value of y is less than epsilon. Pictorially, what that means is I say, okay, here's my epsilon and my minus epsilon, and I just want my y value to lie in between. Okay, so that's my u epsilon. And every point in this strip is going to map into this epsilon band around 0. Okay, so since I was able to find this u epsilon, that means the limit does exist. So therefore, the limit as xy approaches 0, 0 of x squared y over x squared plus y squared really does equal 0.